continuing on with exponents, and for this problem we are going to need to use our order of operations, our commutative and our associative properties also. So these are two separate problems. Looking at this one, you see the sets of parentheses. So that's going to be the associative property, and we are going to get rid of the parentheses because all their meaning is that you are multiplying. So I do not need the parentheses here for this. So now I have undone the associative property. Now I'm going to use my commutative property, and I'm going to rearrange these things. I'm going to put all of my numbers first. So the only number I see there is the -5. So I'm putting that down first. Then I'm going to put all of my letter A. So I have A to the 4. And I have negative A to the -4. Let me double check and make sure that that's right. So I'm going to look at my problem itself. And yes, that is right. The -4 is not on a set of parentheses. The -4 applies only to the A. So the negative sign is going to come out into the front. So what I'm going to do here is I'm going to multiply in a 1. And then I'm going to pull that -1 out to the front. And then I'm going to take my A to the -4, bring it down to my line. Okay, I have all of my A's. Now I go to my B's. B to the -7, B to the 3. I have all of my letters and numbers copied down. Multiply my number parts. Negative times negative is positive. 5 times 1 is 5. So that gives me just 5. Apply my property for when I am multiplying bases. Same base, add the exponent. So I have A to the 4 plus -4. Again, here, I'm multiplying the bases, so I add my exponents. So that's B to the -7 plus 3. Carry this forward. 5 is just 5. A to the 4 plus -4 gives me A to the 0. B to the -7 plus 3. The 7 is bigger, so we know is going to be negative. So 7 minus 3 is 4, so -4. It's still not done. 2 more things I have to do with this. 5 just gets carried down. Nothing more I can do with that. A to the 0. Well, anything raised to the 0 power is equal to 1. So that drops out. It turns into 1. And anything times 1 is itself. So I don't need that A to the 0 at all. B to the -4. Because of that negative sign there, that means that I'm going to put that on the bottom of the fraction. B stays the same. Get rid of the negative sign, keep the 4. Now I have my answer. Moving over to the other side. going to apply my -1 to the 4. There are two ways of doing this. Okay, so watch both ways. Apply my -1 there. That gives me 1 over 4 to the 1 times x to the 5, all still being raised to the -2. I'm going to simplify this. That gives me x to the 5 over 4 to the 1. 4 to the 1 is just 4. It's all still being raised to the -2. Now I'm going to distribute the, actually, I'm going to take care of this negative sign first. So negative sign, it's going to flip the fraction. So it's flipping over on itself. So this becomes 4 over x to the 5. And now it's being raised to the +2. So all I did was flip the fraction over and get rid of that negative sign. Now I am going to distribute that 2 into there. So this is giving me 4 squared over x to the 5 squared. The 4 squared, that's easy enough, that's 16. Over x to the 5 raised to the 2. So I have my exponent, parentheses, squared. So I'm going to multiply my exponents. So that is x to the 5 times 2. Gives me 16 over x to the 10. And there is my answer. So that was method 1. Let's look at a second method. With the second one, I'm going to distribute my -2 in right away. So we are starting out with 4 to the -1, x to the 5, all being raised to the -2. So I'm going to take that -2 and I'm going to distribute it into each of those. So that gives me 4 to the -1 to the 2. And x to the 5 to the 2. I forgot my negative sign. Don't lose your negative signs. They're small, but they're important. Now I need to take care of my exponent, close parentheses, another exponent. These get multiplied. So this is 4 to the -1 times -2. This one, same thing. X to the 5 times -2. Negative times negative is positive. 1 times 2 is 2. So I have 4 to the 2. X, 5 times -2, so I have a positive times a negative gives me a negative. 5 times 2 gives me 10. Almost done. 4 to the 2, that's 16. Over, I want to get rid of that negative sign, so this is going to be x to the 10. I move it from the top of the fraction to the bottom of the fraction. This is the same as that. So there is more than one way to work this out. And you get to choose which one of these two you want to use. The important thing about being done is that we do not have any negative exponents. Until you get into calculus, that's what you want for your answer. No negatives on the exponents. So the next problem we have 5 to the negative 1 z to the 7 over 5 to the negative 2 z to the 9. You'll notice that I crossed my z's. That's so you can tell the difference between a z and a 2. If I didn't cross my z's, it would be really tough to tell the difference. So what I'm going to do with this is I'm going to split it up. I'm going to split my number parts away from my letter parts. So I have 5 to the negative 1 over 5 to the negative 2. This is my associative and commutative properties. I have the z to the 7 over z to the 9. Now I'm going to apply my rule for when I have division and I have exponents involved, and I'm going to subtract the exponents. So this is giving me 5 to the negative 1 minus, because it's division, negative 2. So I have negative 1 minus negative 2. That's a double negative there. So that's going to turn into a plus a positive. Okay, so pay attention to that. Then I have z, same base, top and bottom here. Exponent on the top is 7 minus exponent on the bottom is 9. So with my 5, negative 1 plus 2, that's 1. My z, 7 minus 9, that's negative 2. Not done yet. I still have a negative as an exponent. So now I have to get rid of that negative on the exponent, which means I take this whole thing to the bottom of the fraction. So I have 5 to the 1 is 5 over z, get rid of the negative sign, keep the 2, z to the 2. 5z squared. 5 over z squared. Last one for this set of questions. Open parentheses, r to the negative 2, s to the negative 3. All over r to the negative 4, s to the negative 3. And all of that raised to the negative 3. That looks like a big mess. It's not so bad, trust me. Again, just like I did with this, I'm going to split it up. Here I had numbers and letters. Here I have R's and S's. So I'm just going to split it down the middle. I have r to the negative 2 over r to the negative 4 being multiplied by s to the negative 3 over s to the negative 3. And all of it being raised to the negative 3. I use my rules just like I did over on this problem. So I'm dividing. So it's going to be exponent minus exponent. So r to the negative 2 minus negative 4. And it's being multiplied by s to the exponent negative 3. Divide turns into minus exponent negative 3. Close that off, and it's all raised to the negative 3. I see my double negative here. That's going to turn into a positive. See my double negative there? That's going to turn into a plus. So now I have negative 2 plus 4 gives me 2. And I have negative 3 plus 3 gives me 0. So I have r to the 2, s to the 0, and it's all still raised to the negative 3. Looking at this s to the 0, that equals 1. Anything raised to the 0 power equals 1. So all I really have left is r squared in the parentheses raised to the negative 3. So now I want to use my rule for I have something in parentheses raised to a power, and then the parentheses themselves are raised. I have to multiply the exponent times the exponent. So this is r to the 2 times negative 3, which gives me r to the negative 6. 2 times negative 3, positive times negative to negative. 2 times 3 is 6. Almost done. Still have this negative exponent though. Can't have negative exponents until you get to calculus. So I want to flip this to the bottom of the fraction. So that gives me r on the bottom, the 6 is on the r, and I multiply in that 1, so I have something on the top. And there is my answer. There are other ways that you can do this. You can distribute the negative 3 out to everything inside that's being multiplied or divided. But in this case, that would take longer. So we just want to simplify, simplify, simplify until you can't simplify anymore. Then apply the exponent on the outside. So it's kind of like using your order of operations. You want to do the parentheses first. You want to do what's inside the parentheses first, then anything outside of the parentheses. Okay, that is it for this part of the lecture. Now we move into scientific notation in the next section. And I'll be right back with that.